Hey everybody, how's it going? In this video, we'll be learning about special methods that we can use within our classes, and some people call these magic methods. Now, these special methods allow us to emulate some built-in behavior within Python, and it's also how we implement operator overloading. So what I mean by that is, for example, when we add two integers together, so down here I'm going to print out 1 plus 2, and when we add two strings together, so I'm going to print out A plus B. If I run this code, then you can see that the behavior when we add two strings together is different than when we add two integers together. So the strings were just concatenated and the integers were actually added together. So depending on what objects you're working with, the addition actually has different behavior. And also, if we were to print out our employee instance here, then you can see that we just get this vague employee object. And it would be nice if we could change this behavior to print out something a little bit more user-friendly. And that's what these special methods are going to allow us to do. So by defining our own special methods, we'll be able to change some of this built-in behavior and operations. So these special methods are always surrounded by double underscores. So a lot of people call these double underscores dunder. So if you ever hear someone say something like dunder init, then they mean init surrounded by double underscores. So speaking of dunder init, that is a special method that we've already been using and are familiar with. And it's probably the first and most common special method that people use when working with classes. So just like we learned in previous videos, this special dunder init method is implicitly called when we create our employee objects here, and it comes in and sets all of our attributes for us. So let's take a look at some other common special methods. So two more common special methods that we should probably always implement are this dunder repr and dunder str. Now these are what are implicitly called anytime we run repr on one of our objects or str on one of our objects. And these are what we're going to use to fix our problem of printing out this vague employee object when we printed out our employee instance here. Now I have an earlier video on the difference between these two methods, but in short, repr is meant to be an unambiguous representation of the object and should be used for debugging and logging and things like that. It's really meant to be seen by other developers. And str is meant to be more of a readable representation of an object and is meant to be used as a display to the end user. So let's go ahead and write code for these and take a look at the difference. So first, we want to be sure to at least have an repr method, because if we have this without an str, then calling str on an employee will just use the repr as a fallback. So it's good to have this as a minimum. Now a good rule of thumb when creating this method is to try to display something that you can copy and paste back into Python code that would recreate that same object. So for example here, if I was to come in here and return so we would want this to be something that we could use to recreate this object. So I'm going to say employee, and then in quotes, I'm just going to put a placeholder there. And I'm going to do quotes again for the last name, and then I'll do another placeholder for the pay. And then I'll just go ahead and create a format string here. And let's do self.first, self.last, and self.pay. So again, what I was doing here is that I was trying to return a string that I can use to recreate the object. So to show you what I mean, let's go ahead and print out this employee 1 again. So first I'm just going to go ahead and comment out these lines here. Now remember, when I printed out this instance before, then we got this vague employee output here. But now whenever I rerun this with this repr method, now you can see that it returned the string that we specified in our repr method. And you can see how if I wanted to recreate this employee object, then I can just copy this output, and it's the exact same thing that we used to create that employee to begin with. So now let's go ahead and fill in the code for our dunder string method. So this is meant to be more readable for an end user. So this is a little bit more arbitrary, but to print out this employee, let's see, I'll just say something like, I'll do a return, and I'll do a placeholder for their full name and a placeholder for their email, and then I'll just go ahead and pass those in. So I'll do self.fullname, and then I'll also do self.email. So now if I print out this employee object again, now it should use that dunder str method instead. So now when we print out that employee object, it's printing out the employee's full name and email address. Now we can still access the REPR and the STR specifically if I was to go in here and print both of these out. And then let me go ahead and close those off, and I'll comment out that. Now really when we run this REPR and STR, what's actually going on in the background is that it's directly calling those special methods. So let me go ahead and copy these out. And instead, it's actually calling this double underscore REPR. And then if I go ahead and grab this, then I'll also print out the STR. And if I run that, then you can see that we got the exact same object by calling those directly. So these two special methods allow us to change how our objects are printed and displayed. Now, to be honest, unless you're writing some more complicated classes, these three methods of init, REPR, and STR will be the ones that you'll probably use most often. But let's go ahead and look at a few more just so we can get an idea of how these work. Now there are also a lot of special methods for arithmetic. So like we saw before when we added those two integers together, so if I was to say print1 plus print2, now if I go ahead and run this, now what this is actually doing is it's using a special method in the background called Dunder add. So I can actually access this directly. If I use the integer object, I can do Dunder add, and I can pass in arguments of 1 and 2. So if I run that, then you can see that that gives us the same result. And strings are actually using their own Dunder add method. So if I use a string object and do a Dunder add and pass in a character of A and a character of B and run that, then you can see that the strings Dunder add actually concatenates those together. So we can actually customize how addition works for our objects by creating that Dunder add method. So let's say that with our employee class, we wanted to be able to calculate total salaries just by adding employees together. Now that's kind of a contrived example because if I was to make a class like that in real life, then it's probably better to be explicit about what you're adding together. But just for the sake of this example, let's go ahead and see how we do this. And we'll look at some better real-world examples from the standard library here in just a minute. So if I wanted to add two employees together and have the result be their combined salaries, then we're going to have to create a Dunder add method. So I'll go ahead and do that. And this is going to take in self, which is going to be what's on the left side of the addition, and other, which will be on the right side of the addition. And for this example, we're just going to assume that these are both employee objects. So we want to return self.pay and added to other.pay. So when we add two employees together, it's going to give us their combined pay added together. So let's go ahead and see if this works. So here I can just print out employee 1 plus employee 2. And if I go ahead and run that, you can see that when we added these two employee objects together, that it gave us their combined salaries. Now, if we didn't have this Dunder add method and I copy and I comment out that, then you can see if I try to run that, then it gives us an error here and it says that it doesn't know how to add these two employees together. So if we put that back in, then we are telling it how we want to add these employees together. So if I run that, then you can see that that works. Now there are all kinds of these special methods for arithmetic, and if I go to the documentation here, you can see that there are special methods for subtracting, multiplying, dividing, and plenty of others. So let's go ahead and run through one more example here before we look at some of these real-world examples in the standard library. So if you have ever used the len function to check the length of a list or a string, now this is also a special method. So if I wanted to print the length of a string, so for example, I could say print len of the string test, and let me go ahead and get rid of that print statement there. If I run that, you can see that that string is 4 characters long. Now this is also just using a special Dunder method in the background. So if instead I was to print test, and on that string object, I could actually specifically run that Dunder length method. And if I run that, then you can see that we get the same result. So if we want this len function to work on our objects, then we'll have to create a Dunder len method. So let's say that, for example, when we ran len on our employee instance, that we wanted it to return the total number of characters in their full name. And maybe this could be useful if someone's writing a document and needs to know how many characters the employee's name will take up. So I can create this Dunder len method just by saying def Dunder len, and this is only going to take in self. And now for this, I just want to return the length of self dot full name. So now we can actually use this len function on our objects. So if I was to pass in employee 1 here and print that out, then you can see that we get 13 characters when their full name is printed out. Now there are a ton of other special methods that we could go over. So you can use these to customize how objects are compared, how they check for equality, and a lot of other useful stuff that we're not going to be able to fit into one video. But if you go to the documentation, then you can see a short description of all the ones that you can use, and I'll put a link to that page in the description section below. So now let's go ahead and take a look at some real-world examples in the standard library so that we can see how useful these can be in real code. So I've got the datetime module pulled up here. So in the datetime module, I'm just going to do a search here for Dunder add. So the first result that we land on here is from the time delta class. And you can see that they are checking if the other object that they're adding against is another time delta. And to add those together, they are just returning another time delta with the days, seconds, and microseconds added up from both of those. And if the other object isn't a time delta, then it's going to come down here to this return not implemented. Now that's something that we didn't go over in our examples, but basically when they return not implemented, they don't want to throw an error because the other object might know how to handle that operation. So returning not implemented is a way to fall back on the other object to see if it knows how to handle the operation. And if none of them know how to handle it, then it'll eventually throw an error. Okay, so let's go ahead and take another look at another example. So I'm going to search here for the date class. So now we're here within the date class, and I'm just going to scroll down here a little bit. And here we can see that they have their Dunder REPR method. And you can see that they give some examples of what the output should look like. And just like we talked about earlier, it looks just like how you would create a date object. And if we scroll down a little bit further here, now here we can see that they're setting their Dunder string method equal to the ISO format function. So when you print the date, it'll actually print out the ISO format. So that's pretty interesting. So you can see how learning about these things makes it a little less intimidating to look around in the standard library. And it makes it a little easier to just be able to look under the hood and see what's going on. Now, don't get me wrong, there's a lot of complex code in here, but learning how these special methods work is a big step towards better understanding a lot of what's going on in here. Okay, so I think that is going to do it for this video. I hope this gave you a better idea of how these special methods work and what's going on in the background when you're performing some of these operations. But if you do have any questions about what we covered in the video, then just feel free to ask in the comment section below, and I'll do my best to answer those. If you enjoyed these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up, and also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.